Hello everyone, I, Pragati Baranwal, a volunteer at Shiviforensics, welcome you all to another educational video on the topic food adulteration. In this video, we're going to learn about common food adulterants and how through simple color test we can analyze if our food is adulterated or not. Later, we'll also see how instruments can be used for the analysis of food adulterants. So, what is food adulteration? The action of making something poorer in quality by the addition or subtraction of a substance is adulteration. And what is food adulteration? It is basically the addition or subtraction of any substance to or from the food so that the natural composition and the quality of the food substance is affected. Now we'll see the characteristics of adulterated food. Adulterated food may have a change in its color, in appearance, in taste, and because of certain additives, again the taste and the flavor it gives might change. It may lead to food poisoning issues, allergic reactions to individuals. It may induce vomiting and also stomach disorders. The shelf life of the food product may be increased or decreased in comparison to the original food item. Now we'll see an important act which is related to the food adulteration, which is the Prevention of Food Adulteration Act of 1954. This act makes provisions for the prevention of any type of adulteration of the food items. It was enacted by the Parliament in the 5th year of the Republic of India. PFA, which is the Prevention of Food Adulteration Act, was amended in the year 1964, 1976 and lasting in 1986, 2001, 2002 to make this act more stringent. The main objectives of the PFA Act is to ensure that pure and wholesome food is being provided to the consumers. It ensures the protection of consumer from fraudulent and deceptive malpractices. It maintains the quality of foodstuffs and edible substances. It also prevents adulteration of food stamp. If anyone is found guilty of violating the rules of the PFA Act, where a case of proven adulteration is found, 6 months of imprisonment and a fine of 1,000 rupees is charged on the culprit. Also, adulteration which causes grievous hurt or death to any consumer, a life imprisonment and a fine of rupees 5,000 is charged. Now we'll see what FSSAI is. FSSAI stands for Food Safety and Standards Authority of India. It was established under the Food Safety and Standards in 2006. It is under the Ministry of Health and Family Welfare, Government of India. It was created for laying down science-based standards for articles of food to regulate their manufacture, storage, distribution, sale and import to ensure availability of safe and wholesome food for human consumption. Their aim is to establish a single reference point for all the matters relating to food safety and standards by moving from multi-level, multi-departmental control to a single line of command. It consolidates various acts and orders that have hitherto handled food-related issues in various ministries and departments of India. Apart from FSSAI, we have some food standards like Codex Alimentarius, PFA standards, AgMark standard and Indian Standard Institution, that is ISI. Now let us look at the types of adulteration. Adulteration is subdivided into 3 types: intentional, metallic and incidental. Intentional adulteration includes adulterated things like sand, marble chips, stones, mud, chalk powder and etc. Metallic adulteration includes arsenic from pesticides, lead from water, effluent from chemical industries, tin from cans and etc. Incidental adulteration includes pesticide residues, droppings of rodents, larvae in food, etc. Now we'll see some common food items, the common adulterants and the harmful effects it imposes on our body. The first one is milk. For milk, the common adulterants are unhygienic water, chalk powder, soap powder, hydrogen peroxide and urea. The effect it has on us are food poisoning, heart problems, cancer, vomiting, and nausea. The second is oil. The adulterant is argemone seeds and oil, which impose epidemic dropsy and severe glaucoma. Next we have ghee. The common adulterant are vegetable oil and animal body fats. The harmful effect it has are anemia and enlargement of heart. Next, chili powder. The adulterants are brick powder and sawdust. It imposes stomach problems on an individual, and also artificial colors can cause cancer to one. Next up we have the turmeric powder. The common adulterants are yellow aniline dye and some non-permitted colorants like methanol yellow. It is carcinogenic in nature and also it can cause stomach disorders. Next, black pepper. The common adulterant are papaya seeds, which causes liver disorders and also stomach disorders. Next, tea powder. Adulterants are used tea leaves, dye or artificial color, and iron fillings. They may cause cancer and also tetanus. Next up, coffee. The common adulterants of coffee are chicory powder, ground tamarind, and date seeds. They may cause diarrhea, stomach disorder, giddiness, and joint pain. Now we have honey, where the common adulterants are jaggery, sugar, and corn syrup. These may cause obesity, diabetes, eyes, and nerve damages. Next, sugar and salt. It is a very common food item which is adulterated, and mostly it is chalk powder and white sand. Both of them can cause stomach disorders. Now we have fruits. The common adulterants are calcium carbide and ethifone, which increases the growth rate of the fruits. The harmful effects are digestive issues and respiratory problems. And at the end we have flour, in where the adulterants are chalk powder and adulterated flour. The harmful effect it has are digestive problems and reduced nutritional value. Now we'll see some color tests which we can perform to determine if any adulterant is present in a food item. First we have the milk. To check if the urea is used as an adulterant, we take a teaspoon of milk in a test tube and to which we add soybean or pigeon pea powder. The contents are mixed thoroughly by shaking the test tube, and after 5 minutes a red litmus paper is dipped in it. If any change in color is observed, most likely that is red from red to blue, it indicates the presence of urea in the milk. Second, detergent. We take 5 to 10 ml of sample, which is milk, and we add an equal amount of water to it. If any formation of foam is observed, it might indicate that the presence of detergent is there in the milk. Second, we have oil. The most common adulterant is any prohibited color. So, we take 2 ml of the sample in a test tube, to which we add 2 ml of concentrated HCl. It is shaken gently and it is let for standing for 5 minutes. If the color separates in the upper layer of the solution, it indicates that a prohibited color has been used in the oil. Next up, we have the chili powder. To check if brick powder has been used as an adulterant, we take a small amount of concentrated HCl and we add it to the sample of the chili powder and we mix it so that the consistency of a paste is achieved. We dip the rear end of a matchstick into the paste and hold it over the flame. Brick red flame color due to the presence of calcium salt in brick powder is observed. Next, we have the green chili and green vegetables. The adulterant for testing is malachite green. We take a cotton piece soaked in a liquid paraffin and we rub the outer surface of the small part of the green vegetable. If the cotton turns green, we can say that the vegetable is adulterated with malachite green. Next up we have ghee. The adulterant is vanaspati or margarine. For detection, we take a teaspoonful of melted sample of ghee with an equal quantity of concentrated HCl in a stopper test tube, and to which we add a pinch of sugar. It is shaken for a minute and it is allowed to let it stay for 5 minutes. Appearance of crimson color confirms the presence of vanaspati or margarine. Now, jaggery. The adulterant is washing powder. To detect the presence of washing powder in jaggery, we add a few drops of the solution of HCl to the jaggery sample. If effervescence is observed, we can estimate the presence of washing soda in it. Now, pulses. To check for the presence of lead chromate in it, we shake 5 grams of pulse with 5 ml of water and a few drops of HCl. A pink color indicates the presence of lead chromate. Next, turmeric powder. To check for presence of any colored sawdust, we take a teaspoonful of turmeric powder in a test tube to which concentrated HCl is added. Instant appearance of pink color, which disappears on dilution with water, shows the presence of turmeric. If the color still persists, maternal yellow, which is a non-permitted coal tar color, might be present. Now, common salt. To check for the presence of white powder in common salt, we stir a spoonful of sample of salt in a glass of water. The presence of chalk will make the solution white and the other insoluble impurities will settle down. Next, we have iodinized salt. To check if common salt is present in it, we cut a small piece of potato and we apply salt over it. We wait for a minute and then we added 2 drops of lemon juice to it. If iodized salt is present, blue color develops, but in the case of common salt, there is no blue coloration. Then we have tea. To check if exhausted tea has been used as an adulterant, we spread a little slate lime on a white porcelain tile or a glass plate, to which we sprinkle a little tea dust on the lime. Red, orange or other shades of color spreading on the lime will show the presence of coal tar color. In case of genuine tea, there will be only a slight greenish yellow color due to the chlorophyll which appear after some time. These color tests were only the preliminary analysis. To confirm the presence of any adulterant present in a sample, we need to use high-end instruments, which we're going to talk about now. The first one is UV visible spectroscopy. As we all know, it is based on the principle of Beer-Lambert's law. This instrument can be used for the detection of color and fat oxidation products. Example, in oil industry, it can be used to determine quality of oil by measuring anisidine, which is generated during oxidation of food. It also determines the total oxidation value, that is TODOX, which indicates the fat deterioration. It is measured at 350 nanometers. Second, we have the fluorescence spectroscopy. It is based on the emission of light after the absorption of UV or visible light by fluorophores. This can be used for the detection of fluorescence based on a naturally present fluorophore within the sample. Example, dairy and honey industries, meat and seafood. Next, we have the Raman spectroscopy. It is based on the scattering of incident light at an energy shifted by the vibrational energy of the molecule. This can be used for the detection of carbohydrates, proteins and fats within the food. It also detects the degree of unsaturation of cis and trans isomers and alterations of food. Example, olive oil quality check, composition of wheat. Next, we have the atomic emission spectroscopy. It uses the intensity of light emitted from flame, arc or spark at a particular wavelength to determine the quantity of element. It can be used for the detection of major, minor and trace elements in any food item. To conclude, we can say food adulteration remains a significant challenge globally, affecting the food safety, public health and consumer trust. Continuous efforts from the regulatory bodies, technological advancements and consumer vigilance are essential to combat this issue and ensure food integrity. If you want to learn more about food adulteration, you can refer these links for your references. Thank you so much. I hope it was an informative video. To learn more about topics related to forensic science, do visit the YouTube channel of Shivi Forensics.